Hi guys, this is Mr. Ward. This is day 6 of Unit 8B on logarithms. We spent a day or two crunching numbers, learning how logs work. We did a little graph theory. We learned some equations in a vacuum. Now we're going to learn equations with some applications both today and tomorrow. All these formulas you're familiar with: exponential growth, 1 plus r, slowest, e, fastest, and any other compounding with n somewhere in the middle. Half-life is a decay where the base is always 1/2. All right, let's take an application here. I'm going to add another question to it. I don't like this first one. It says a 1996 Dodge Caravan cost $15,860 brand new. The depreciation on this vehicle is 6.5%. That means per year. I'm going to call Blue Book. Let me do that in blue since it's Blue Book. Blue Book means what it's worth today. So how would I do that? Well, my formula is amount anytime equals initial amount, 15,860, decaying 1 minus 0.065. I'm doing the 1 minus r to the t. Okay? And now we know the year. So if it's today, 2021 minus 1996 is 25 years. That's going to go right there. So the A equals 15,860. 1 minus 0.065 is not 0.935, but I'll leave it as that because it's losing 6.5%, so it's worth 93.5% to the 25th power. The Blue Book value today would be $2,955. Okay? To make it a more interesting question, that's a typo. I should have said, when is the value of the car? Well, we can go 250. That would be like salvage value, when it's worth just kind of scrap. And I'm going to do it the other way. Instead of using the 1 minus r, I'm going to use the PERT. So we have amount equals initial, e to the RT, initial 15,860, e, I know what r is, 0.065. In what year, I don't know the time, but I do know how much it's going to be worth, and that is $250. So what do I got to do here to solve for t? I got to divide off that 15,860, and I get 0.01576 equals e to the e to the negative, because decaying, 0.065t. What do I do next? To get that variable down, we either get the bases the same, impossible, or take a log, in this case a natural log. 0.01576 equals, if I do ln of that, I shoot it down front, I end up with this. And you can skip that step right there. So again, calculator inactive, I can find the answer as long as I accept this as my answer. Now I can plug that into my calculator, and we can find when it's worth $250. It's probably going to be a while. Salvage value, let's see, ln of 0.01576 divided by negative 0.065. 63.8, I'm going to call that 64 years. If I add that to 1996, I get the year 2060. It would be the year that that Caravan is worth down to $250. But again, solving an exponential equation that's got a meaning to it, not just simply math in a vacuum. Okay? We did a little bit of 1 minus r. We also did PERT. Either one would be acceptable unless I dictate it to you otherwise. Okay, exponential growth. A e to the bx, exactly the same as always. Use this model to find x when y equals 1500. So let's first set it up. If I know 0, 2, what do I know? A is 2. So what do I have? I have y equals 2 e to the r, I'll use the same letters, pardon me, bx. and I have an ordered pair. You should probably remember this from last unit, xy. If I throw the 26 in here, 2e to the 3b power, I'm going to isolate, divide by the 2, I get 13, ln 13, pardon me, 13 equals e to the 3b. Now I'm going to take the ln of both sides. ln of 13 equals 3b. b equals ln of 13 over 3. What's that number? ln of 13 over 3 is 0.855. I just found the b value, the growth rate. So now I have my model. So the equation is now y equals 2e to the 0.855x. And if I want to find x when y is 150,000, I'm going to plug that in for y and solve for x. Divide off the 2, 75,000 equals e to the 0.855x. Take the natural log. I'm going to skip that right step and just call it this. Divide ln of 75,000 by 0.855, and I get x equals 13.129. Again, that's more of math in a vacuum, but it's just practice solving equations with those variables up there. That is the use of logarithms. All right, we're going to revisit a modeling question we talked about last unit, because again, exponential and logarithm, they go together, okay? Houston, we're going to use Houston only, we won't use Detroit. We just did a negative R, we got a positive R. Houston's growing. In 1990, there were 2.3 million. In 2000, there were 2.65 million. Find the exponential growth model for Houston and Detroit. I'm going to use PERT. No, actually, you know what? Let's use the other one. So A equals initial year 2.3, 1 plus R, and in the year 1990 was 0, so 2000 would be the year 10. We're going to solve this equation. We're going to set A equal to 2.65. So how do I solve this? Divide by 2.3, no doubt. 1.152 equals 1 plus R to the 10th. Now, do I take a log here? The answer is no, because R is down where we can solve for it. The first thing we got to do is undo the 10th power, which means we take the 10th root, or raise it to the 1/10th power, which means the same thing. 1.152 to the 1/10th power is 1.014 equals 1 plus R. Subtract 1.014, or 1.4% growth per year. That's a pretty fast growing city. Doesn't sound like a lot, but 1.4% is a tremendous amount. All right, let's do number 2, or letter B, 10 million people. If Houston kept at this same growth rate, which it probably wouldn't. There's a lot of factors that enter into that. But how would we find 10 million? Well, first of all, the numbers were in millions, so therefore 10 million equals 10 million. That's what we're going to throw in for A. 10 equals 2.3. Let's use E this time. E to the, well, no, we can't do that since we did the 0.14 as, even though it's close because I did it both ways, we'll stay with the same one. 10 equals 2.3 times 1 plus 0.014 to the t power, because we're looking for what year. Divide off the 2.3, and I get 4.3478. I'm isolating the exponential. I'm going to call this just 1.014 if you don't mind. T is up in the variable. I got to take the log of both sides. I'm going to take the common log this time, even though more often than not I take natural. And I would have t down front, log of 1.014. And now just divide. Whoops. So log of that 4 decimal number divided by log of the other decimal should give me t. And I got t to equal 105.7. So I'm going to call that 106 years from 1990, which would be the year 2096. A long way off, but city planners and managers have to deal with those type of things. But again, practice solving equations that have meaning to them. Okay, I got one more example. It says we have a formula that represents advertising discounting, okay? And what happens to sales? They don't advertise, sales go down. So S stands for number of units sold. T is the year, which is year 0 is 1994. In 96, the company sold 300,000 units. Find the exponential model by finding K, otherwise known as the growth rate, or in this case, decay rate, pardon me. And then we'll predict sales, what they would be in 2020. I think I might have done 2021, but that doesn't matter. All right, we'll use this formula. So number of units sold, S, is 300,000 equals 500,000 over 1 plus 0.6e to the k. And then what year would 96 be? It would be times 2, or 2k. We're going to solve that equation. Let's cross multiply first. 500,000. Get the variable at least out of the denominator. Equals 300,000. Parentheses 1 plus 0.6e to the 2k. Isolate the exponential. Divide by 300,000, which gives me 5/3, right? 1 plus 0.6e to the 2k. Subtract 1. 5/3 minus 1 is 5/3 minus 3/3, which is 2/3. 2/3 equals 0.6e to the 2k. Divide off the 0.6. Otherwise known as 6/10 or 5/3. We could do this in our head by all means. And what we get is e to the 2k equals 10. Oh, I didn't write that down, darn it. What is it? Well, let's see. Let's do this right here real quick. 2/3 divided by 6/10 is 2/3 times 10/6 or times 5/3. So that would be 10/9. And again, you could use your calculator. Let's take the ln of both sides. 2k equals, again, great question. Haven't touched our calculator yet. 10/9. K equals ln of that 10/9 divided by 2. K equals 0.053. There is our sales decay rate. Now, the reason why it's a positive number, it's decay, because it's in a denominator. All right, and then what does it say? What's the sales in the year 2020? Well, 2020 would be T equals 26. Let me do another color. T equals, 25, my bad. So now I have S equals 500,000. 1 plus 0.6 e to the 0.053 times 25. And that's just a plug and chug. I get 153,500. So I'd expect sales to go all the way from 500,000 down to 300,000, down to 153,500 just by dropping advertising. All right, looks like time is almost up. That's perfect. We got through day 6. Again, watch this again if you need to, but what are we doing? We are using a lot of logarithms in these exponential growth equations to solve for unknowns. Sometimes they're rates, sometimes they're times. Great job, guys, and we'll see you next for day 7.